Does anyone want to take a guess at what our next panel is? Okay, I didn't tell you. So our next panel is going to be about sustainable energy systems, right? Think about your wind power, your nuclear power, your solar power, and we're going to try to put a little bit of a mechanical perspective to it as well, but it will be general to a degree too. So that being said, I'm going to kindly ask our panelists to get to the stage. Give her a round of applause.
You try to take away my sanity. Maybe it ain't for me.
Hi everyone, and thank you for attending Industry Night today. My name is Pramti Krishnan. I'm a space engineering student and also the president of York University's Robotics Society.
Hi everyone, my name is Shisa. I am a third-year computer science student here at York University. I am the chapter lead for NAYGN, or North American Young Generation in Nuclear, and I'm also the events chair for IEEE York University. We are so happy to be here today to be your panelists. We are your moderators today for the mechanics panel, so give up a round of applause for our lovely panelists over here.
As Corda mentioned, tonight's panel is on sustainable energy systems, a pressing topic as our world continues to adapt to new technologies, and the question for engineers today is how should we navigate this new opportunity? Without further ado, let's introduce our panelists.
So if we could just have the panelists one by one introduce themselves, their background, their name, as well as one fun fact about themselves to break the ice.
I think it's my turn first.
Yep.
Yeah.
Hi, everyone. Nice to see you all here. My name's Animesh Roy, and I'm the energy manager at Toronto Metropolitan University, formerly known as Ryerson University. And my role within that organization is basically to map out and implement a decarbonization strategy by 2045 for that institution. Fun fact about me, kind of put me on the spot, but I have been on the cover of Time magazine. Not featured, I was just an extra. They needed a brown guy on the side, so my friend was doing the shoot, so I made it in, though.
Yeah.
Hi, everybody. I'm Tom Cooper. I'm a professor in mechanical engineering. I predominantly work on solar energy research, but that spills over into other renewables as well. And all the fun stuff that goes alongside that, like thermal sciences, fluid dynamics, and all the complementary streams of mechanical engineering that fall under energy. Something fun about me, as my capstone teams know, I love bikes. I love riding bikes. I think they're a great way to get around, very sustainable. So that might tie in a little bit to our discussion today as well. Thank you.
Yeah, great.
Magdelena. I'm a civil engineering professor here at Lassonde, so I am not a mechanical engineer, but I do work with energy systems when it comes to sustainability. My background is a contaminant hydrogeologist, so I look at the movement of contaminants in the subsurface. Fun fact about me, I just thought of this because I saw a spot over there. My husband works for Bus Dynamics, and so when our son was 2, he actually sat on a spot, but when it was first being brought out, and so it had wires all over the place. But he survived, so yeah, I know Spot very well.
They call us. Hey
everyone.
Nope. It's not us.
Hey everyone, Breden Bradshaw from OPG. I'm an electrical engineer and I work in our innovation team at OPG. So what that means is we do a variety of different types of innovation at OPG: online monitoring, additive manufacturing, and robotics. And what our team basically does is we develop those solutions for our stations. We find ways to modernize our stations and bring this new technology that's in our world to implement those on those stations. So looking forward to talking more about that.
Hi, Rajeev, Leekha. I'm a director of design and design theory for Pickering Station. I've been with OPG for 26 years. So I've worked in Pickering and Darlington, and I also worked in nuclear waste. And I was also accountable for the first unit refurbishment in Darlington. That was experience. So what should I? The best thing is what I really enjoy in my side of it, in my business world of it. Although I'm mechanical by profession, but my experiences gets into everyone having a discussion with all different disciplines: mechanical, electrical, civil, mechatronics. It's interesting. I look to see at the mechatronics because when I was about 15, 20 years ago, somebody asked me a question is what the industry wants. So I said if they need something who understands the INC side, electrical side, and mechanical, is mechatronics showed up, and I'm really happy to see that. And I enjoy my time. I got two daughters, and they keep me busy, and I enjoy the time with my family. That's my fun part in the personal life. That's all I have. Thanks.
Thank you so much for sharing some facts about yourself as well as who you are. Now let's kick things off with the first question. How would you define sustainable energy within the scope of your work? This is a free-for-all question, so anyone could take it.
All right.
I'll get us started here. So I teach an energy course in fourth year mechanical engineering. So we go through the topic of sustainability in the context of energy systems in that course. So I'll just have to recite some of my notes from that course. By the way, if there are any mechanical engineers in the room who are interested in energy, that is a good course to consider taking in the winter fourth year. So when we think about sustainability in the context of energy systems, for me, there are two things we need to think about. So the first thing to think about is sustainable and renewable are not the same thing. They have different meanings, right? So renewable means that it's continually replenished, whereas sustainable means not necessarily that it's renewable, but that it can be utilized in a sustainable way. And the other thing that factors in there is green, right? So green has this meaning of having minimal impact on the environment and perhaps even on society, right? So when we think about sustainable energy, we have to think kind of beyond whether it's renewable or not, but also whether we can use it in a sustainable way and what are the ways that we can minimize impact on the environment and also on negative impacts on society.
Yeah, thank you. For me and our institution at TMU, basically we've defined it in our sustainability action plan as means of meeting our energy needs today without compromising future macro and micro ecosystems or the ability of future generations to meet their energy needs as well. So now what exactly does that mean in today's global context? Obviously that means utilizing fuels that can be extracted, utilized, and if needed, disposed of safely, and also in a way that doesn't, in most practical senses, in a way that does not emit greenhouse gases that are contributing to large-scale climate change as we're seeing right now.
I would just add end life to that discussion. I deal with the disposal of nuclear waste. So you have to ensure that at the end of the life of any energy system, you also have a plan for that. Whether it's nuclear fuel storage or, I don't know, getting rid of a solar panel, that you're thinking about the end of the energy system as well.
Thanks. I guess in the context of OPG, sustainable energy systems, we're primarily in the nuclear side and then the hydroelectric side too. Nuclear accounts for 50% of Ontario's base load right now. And with all the data centers and the energy focus in Ontario, we do expect that the energy usage goes up energy generation goes up about 75%. And to combat that, we're looking into other sustainable energy systems like the SMR project that's going on in Darlington, which is looking at being online in about 2030, and lots of other refurbishment projects going on at Pickering. So it's a big focus right now on us to kind of refurbish our stations and ensure that we have that long-term sustainable energy to provide.
I think it makes my life easy, sitting at the end. So definitely being in a nuclear is all about the zero emissions, and that's really is the key for the future generation. That really comes on. So if I look at it from a nuclear, as I'm also accountable for safe storage. So looking at it from the perspective is how we get the nuclear power from protecting the future generation. How do we get the energy from protecting the future generation? So having a zero emission has a huge impact for the future generations to come. And from the safe stating it, definitely we have all the mechanism in place to make sure that we produce it safely, and that's our main goal. Is the key for us.
Okay, thank you so much for your innovative answers. It's always nice to hear about different people because they have different perspectives, such as OPG with nuclear or, yeah. Our next question is, what exciting new innovations do you see playing in the future of sustainable energy systems?
I guess I can start with this because in my line of work, we're seeing a huge shift in how we're looking at waste energy. I put waste in quotations because most industrial processes and everyday use of buildings, they tend to generate heat. And what we've historically seen is we've looked at heat as waste that we have to get rid of in the summer and somehow generate in the winter. But now slowly what we're seeing is through the use of industrial processes, through the use of data centers, which are increasing in size, heat is becoming now a valuable commodity that you can potentially sell off to your neighbors. If you don't need heat and they need it, that's not only a new commodity in the economy, but it's a way of minimizing resource waste as well. And so that's one exciting new, not really technology, but a new way of looking at how we used to do things. But that also leads to a new burgeoning industry, which is energy storage. What if you were to store all the heat you remove from your buildings in the summer and find a way to extract that heat in the winter, right? So there's many things going on. I'm sure everyone else on the panel has their own things to add, but for me, what I have been looking at closely, because I'm trying to decarbonize our district steam system on our campus, and I think that's a really exciting technology that we are looking into. Pass it over to you.
Because it's completely related to what you said. So I actually look at that in a different way. I work with geothermal heating, which is what you're talking about, storing heat underground to use it for heating of buildings. But what if you could take that and use it at a contaminated site? So being a TMU, you're urban. There's lots of contaminated sites in Toronto and other urban places. And one way to deal with contaminated sites, and when I say contaminated sites, I mean subsurface. So your groundwater, your soil becomes contaminated through diesel or spills or anything like that. One way to clean it up, what we do as environmental engineers is we heat it up. We heat up the soil and we volatilize those compounds. But we have to inject that heat, and that costs money. But what if we can have heat that's already being used to heat up houses or for data centers? What if we use that heat to actually remediate the soil at the same time? So 2 for 1. So that's the type of research that I'm working on. So it's very related to what you're talking about. We should talk. Yeah.
All right, and I'll stay on the topic of heat a little bit here, I guess for all the mechanical engineers in the room. So a very important thing to always remember when we're thinking about energy is that energy does not equal electricity, right? Electricity is a form of energy, but there are actually other forms of energy that are very important in our day-to-day lives. It turns out that 50% of all of the energy we use in the globe, 50%, is used in the form of heat. So the vast majority of the energy we actually use is used in the form of heat. This can be for space heating, water heating, but it can also be for industrial processes that require immense amount of heat, like materials production or drying processes, pulp and paper, things like this. So heat is an extremely important commodity in the context of energy. And so when we think about sustainable energy, we have to think not only of ways of producing sustainable electricity, but also sustainable heat. And the other one that we need to think about is fuels, right? So we use fuels as well, and they're an extremely important component of energy. So we need to think about how to produce sustainable fuels. Fuels are going to be around for certainly the next few decades, particularly for industries like aviation, which are very difficult to electrify. So I think a really important takeaway when you think about sustainable energy systems is we need to think about not only electricity, but also heat, fuels, and other forms of energy that we use.
When you look at like Pickering Nuclear as an example, Pickering Nuclear Generating Station was designed in 1950 into 1960, so it's incredibly old. Some of our hydroelectric stations are even older. They date back to the 1900s. So there is a huge opportunity for innovation for the existing infrastructure that we already have to enable it to operate more efficiently as a business, as a generating station as well. And that's really what the department that I work in, we do. We look at those different opportunities, whether it's online monitoring, implementing sensors to monitor equipment for better reliability, obsolescence issues. So we look into additive manufacturing and 3D printing to replace components that might not be available anymore because some of these stations are so old. Or robotics as well. We're looking into better ways that we can perform inspections within our stations and enable us to, I guess, see things that we couldn't see before that ultimately leads to us with better production and more energy output.
So a couple of things I'd like to add from the innovation perspective. From a nuclear side, you see now we're coming with the medical isotopes. Think about it, all the medical isotopes are used to treat people. And those are very niche. Those are not done everywhere else. And Canada produces a lot of them, and they are sending it, shipping it across the world also. So medical isotopes for people, cancer industry. I just take an example of there. And we talked about the helium. Helium is also used in the airports for detecting any chemicals for a lot of other activities. Those are precious chemicals. Those are coming out from the nuclear industry. It never used to be in the past, but now is more and more advancement are coming up, and now stay tuned, and the more medical isotopes are on the horizon right now, as along with the energy production. I was looking at is as part of my previous job in the nuclear radioactive waste management. Look at it from the perspective is the international community is going in a very different way. They're looking at the waste as an asset. There's a lot of advancements are going on in the international community. How we can leverage this and back into circular economy. So is nuclear industry what was 100 years ago is not going to be the same what we are going to see 100 years from now. There's going to be a lot of benefits are coming up. Pickering produces some of the medical isotopes, and Darlington is also producing it. So there's more and more is come.
Thank you so much for that.
Sorry, if I may,
Yes, sir, sorry.
I just have a question for actually the audience, because I'd like to get to see, it's not every day we get to interact with so many students at the same time. By show of hands, how many of you do you think nuclear is a dangerous source of energy? And how many do you think, okay, one person, and how many think it's safe? Most, okay, that's great. And if, like, from what I know of past nuclear incidents like Chernobyl and Fukushima, the issues were not primarily with the technology itself. It was around the human-centered operations and procedures around it. And I believe in Canada, we use a much safer technology called CANDU, whereas in Chernobyl, they used RBMK reactors. And just to summarize, RBMK, when they fail, it results in a meltdown. And when a CANDU reactor fails, it automatically shuts down. The reason I bring this up is because when we talk about technology, there's a lot of false perceptions on what does work and what does not work. And that's really, I think, as engineers entering the workforce, it's really important that when you look at energy systems, just take yourself outside the box and look at the macro effects as well. Because after Fukushima, for example, Germany got so averse to nuclear that they went back to coal and gas. And then when the war broke out in Ukraine, that resulted in a huge energy crisis in Germany. So these things play out in unexpected ways. And I think in Canada especially, we don't know what the next 50 years will look like politically. And we have to kind of be wary of the intersection between technology and politics within our own country as well.
Thank you so much for that as well. So our next question right here is, surely you've heard of the new SMRs being built within Ontario. Would you have any thoughts on the SMRs being built and what this means for our country and our province?
I can share some of the things, but is I gotta be a little bit be critical, a little bit sensitive to it. SMRs is the first time in the world right now they're producing it, and they're having this installation going on in Clarington site. So that's a real, I will say it's a real I will not call it an innovation, but it's really a pride moment for Ontario, for Canada. This is the only country in G7 who has it. So construction is already in progress. This SMR is going to be there. The three more, what I understand is there may be more coming up, and it's not only in Ontario; it's going to be outside Ontario also. That's all I can share with you. There are certain things I cannot go any further down, but it's very interesting to see. You will see a lot of different change in technology. How is technology change? The mention is Pickering is older plant. The way we manage that plant is very different than what we do in Darlington. As summer is a one step ahead. The lot of steps again. So.
And this next question is geared more to our professors. What role do you think emerging technologies like AI, IoT, and smart grids will play in the future of energy systems? Are there any potential risks or limitations that we should be mindful of? I'd like to start with Amish Roy, because I do know TMU has been working on their own smart grid system.
Yeah, sorry, could you just repeat the first part of the question again, please?
Oh, of course. So what role do you think emerging technologies like AI, IoT, and smart grids will play in the future of energy systems?
I think they'll play a huge role, but I would also be careful not to jump the gun and differentiate what are human problems and what are technology problems. And technology problems will never solve human problems first. What I mean by that is phase one of adopting cutting edge technology, which no doubt AI, for example, this building and every building on campus is controlled by a building automation system. And traditionally what happens is there's a person behind that computer who's looking at how the building's operating, right? That person is on call all the time when the building's operating. AI can replace that person and that 20 other buildings, and before you would have deterministic programming, meaning if X happens, do Y. With AI, through a reinforcement learning algorithm, you don't need that. You program what the ideal condition is, and the computer will study your building automation system and make those changes. So there's no doubt that it will have a huge impact. With smart grid, especially another consideration to make with smart grids, when we talk about climate change resilience, so resiliency when it comes to extreme weather events, what tends to happen is the grids can go out. With a smart grid system, you can kind of anticipate when there's going to be flooding, when there's going to be these inclement weather events, and get your grid ready for that. What do I mean by that? So if you have an electric car parked, if you have a Tesla parked overnight, at night, that could actually help feed into the grid, resulting in less waste of electricity. So I think there's going to be a fundamental shift with how we do things. In the past, over the last 50 years, when you look at nuclear plants, when you look at wastewater collection systems, it's all about centralization. You have these huge facilities that sit in this somewhere servicing an entire city. What you see with things like the SMR pilots, we are moving away to more community-based energy systems, water collection systems. I think that ties really closely into resiliency to do with climate change. So those are just some ways where technology is going to have a huge part. But I will end with how I started. Technology is exciting, but you do have to consider the human factors, because currently what I've seen in my experience, many organizations are not ready for the technology because they haven't perfected their human-centered processes yet.
Thank you so much for your answer.
Yeah, I'll just add a couple points here related to the role of control and smart grids, specifically related to renewable energy sources. So one of the biggest challenges of renewables, so things like solar and wind, is that they're highly intermittent, right? So they produce electricity when the sun shines or when the wind is blowing, but we need energy on demand, right? And so that is an additional challenge that non-base load generation like wind and solar brings, which is a fantastic engineering challenge for us to work on. So there are different ways to remedy this. I mean, one approach would be storage, but another approach would be smart grids, which can hopefully balance between wind and solar, for example. So I think renewables bring this unique challenge where things like AI and smart grids could have an important role in trying to bridge some of the difficulties that these intermittencies in renewables bring. And another challenge that was brought up is the more distributed nature of renewables. They tend to be less centralized versus other baseload power options. So the decentralization of electricity generation brings another challenge that things like AI and smart grids can help to solve.
Professor Magdelena, as a civil engineering professor, how do you what role do you think emerging technologies are in and based in a civil engineering lens?
So we are starting to use AI, if that's what we're talking about when we talk about emerging technologies in civil engineering. Most of it is data collection and then prediction, such as flood warning systems. So we're collecting data on flooding and then looking at, for example, the permeability of soil surfaces and trying to predict what kind of flooding events would be worse or better depending on the climate change or whatever. The other ways that we're looking at is just the interdisciplinary things. So some of the things that we were talking about before, taking something that is already there and bringing another kind of look at it. So taking energy, bringing it back to water, or bringing it to contamination. So linking various interdisciplinary things. Civil engineering used to be very siloed. You'd have structural, you'd have geotechnical, you'd have environmental, but more and more you're seeing the connection between various fields, not even civil, but like mechanical with the energy system. So those are the kind of things that we're looking at.
Okay, thank you so much.
Yep.
Thank you so much. This concludes our panel. So as such, we will take 3 volunteers to ask our panelists some questions.
That was a
So if you'd like to come up, please come up over here, just quietly up on the stage. We'll take up to 3 volunteers.
I guess the question is a little bit more to the nuclear side. In the 70s and 80s, there was a first wave of innovation with the first reactors at Pickering. I believe the second wave of innovation is going on right now with the SMR projects going on in the 2020s to 2030s. What do you see in the next 30 or 40 years? What is the next wave of innovation going to look like in the nuclear side?
So let me a couple of things I'm seeing it today. How the reactors are controlled is changed. It's although they're all safe to for the safe and reliable operation, but the technology to control is changed and monitoring of those reactors is changing. In the past, I just take example of Pickering, the first Pickering, we had a lot of military standards, how we do that, how we manage the reactors. It's the experience we are getting is moved into the Darlington. So the more and more experience is moving into the SMR. These are all the fission reactor. There is other technology is coming. They're looking into it. The different type of technologies are coming up in nuclear. Right now, what we have is the SMR is a one type of technology. The research is going on different type of technologies to produce power from those reactors. Yes, they are coming up in the different part of the world, but let's see how it goes. Those are under testing processes. So,
All right.
I guess another thing, like we are in an age of data now, where we have more data now than ever. And I think that that's being brought to the industrial side too with nuclear. When I joined OPG back in, I think, 2017, we didn't even have Wi-Fi in our stations. right? And now you're seeing IoT devices and Wi-Fi going in. That's going to come with a lot of data as well. And with large language models and AI, we're going to be looking at ways that you can effectively process that data to improve the way that our plants operate. So I think that's going to trickle down into the day-to-day operations in the station too. When people are going out, they're checking pumps, they're checking motors. Now we have the ability to actually check those things from our computers, right? So that's a big change.
So one thing I like to add on there, the basic fundamental is safety. Safety is the one. Yeah. Doesn't matter which technology is going, and that's what that's the basic.
Well, thank you very much. I'm glad to see that nuclear in Canada is a forefront in this industry, and it's something to be proud of as a Canadian. Thank you very much.
Hi everyone, my name is Bobby. I'm a third-year electrical engineering student. I had a question regarding nuclear waste. From what I understand, as a byproduct of uranium fission, nuclear waste is generated and is potentially toxic to the environment. I was curious, so I did a bit of research, and what Google says at least is that this nuclear waste is buried underwater for maybe a few decades, and then later it is transferred in concrete blocks and stored for thousands of years until it is no longer toxic. So I do understand that some countries such as Japan and France, they do have some ways of recycling this and putting that nuclear waste to use by maybe repurposing and finding fuel still remaining. I was wondering, are there any upcoming initiatives or projects that make it possible that to implement that sort of technology here in North America to recycle that waste?
You can probably talk about the recycling. Sure.
Let me take the first one. Well, you mentioned about the having a nuclear, used fuel into the bay for 10 years. Yes, that's a process. We do it to contain our radiation that comes out. Once we go to the safety side of the radiation, then we have a mechanism how we store those, and these are. I just want to be very careful. Those containers you see, those are very well designed for the different design basis events. For the safety is the key, and that's the
I also had, oh sorry, go ahead.
I was going to talk about the Deep Geological Repository, which is Canada's plan, and it's most of the world's plan, which is taking the used nuclear fuel bundles and storing them underground for hundreds of thousands of years. So that is a plan that the Nuclear Waste Management Organization, which is but it's not connected to OPG, right? Is it connected? Anyway, that's their plan for Canada, and they go through a gazillion safety mechanisms, working with industry as well as academics, such as myself. So the one thing that I'm looking at is looking at the corrosion possibility of these nuclear waste containers and seeing what the longevity is. So they're taking safety very seriously. I can't talk about the recycling of nuclear waste. I'm not a nuclear engineer, so I don't know if anybody else can.
I am curious, like after the hundreds of thousands of years, is there a plan to further do anything with that waste, or is it just like kind of an infinite solution to a problem?
There's a half-life for that uranium, so I don't know what the half-life is.
Right,
So after a certain point, it's no longer radioactive, but it's over 500 meters below ground. It is not in groundwater. It is in a tight rock formation.
Thank you, that's very informative.
All right, thank you so much. We're going to wrap up our panel with one last question from the audience.
Hi, my name is Olusanya Todd. I'm a second-year mechanical engineer, and I had an open question in terms of renewable energy and green energy. What are some of the specific, maybe new projects that you're working on that for someone who's on the outside and not really getting to see it, you think would be exciting to know about or exciting to maybe consider internship or co-op working on that new thing?
take it. So there's a huge list. Right now, Darlington went through the refurbishment. Then refurbishment was Darlington refurbishment units went through the whole cycle of it, still finishing it up. Pickering refurbishment project is a huge project. That's just starting it up. It's already started it. The other thing is what I can point it out. SMR, you already heard about it. Those are new projects. in the nuclear industry. If you look at these day-to-day activities, there are so many. I mean, from the other side is safe storage. How we safe state all the units is also is a huge project by itself. When we talk about a huge project, we talk about not in a small like $1 or $2 million. It goes into the huge number, multi-million dollar. The other thing is for day-to-day activities, like right now I have almost like 100 small projects are going on simultaneously to make changes and make improvement for the on all the activities. So it's a huge list. I don't know what else I can give it, how much I can give it.
Okay.
Yeah, I'll just add a couple of cool things that are happening in renewables, because I'm primarily doing renewables, solar and wind. And I'm tying this back to what we were talking before about not only electricity, but heat and fuels. So there's actually a lot of cool work being done now to produce renewable fuels. So these are basically synthetically produced fuels that are drop-in replacements for gasoline or even jet fuel. I actually have some here with me. So this here is gasoline that's been produced from 3 ingredients, and those 3 ingredients are sunlight, CO2, and water. So through a catalytic high temperature process, you can actually convert, you have a source of carbon, that's from CO2, ideally extracted from the air. You got a source of water, you can also extract water from the air. There's more water in the air than CO2. So you got a source of carbon, you got a source of hydrogen. So you can actually produce a liquid hydrocarbon fuel in a completely sustainable and renewable way. And this opens the door to things like sustainable aviation, which is very difficult to electrify. So I think there's a lot of interesting opportunities when we think a little bit outside the box, and finding ways to, increase the share of renewables, not only for electricity, but for also things like heat and transportation fuels.
Thank you.
Okay. Thank you so much for your answer. I know we're all getting hungry for dinner, but I'm hungry. And also starting to hear more about sustainable energy systems from our lovely panelists. So let's give them a hand, everyone. Woo!